Okay. So sum is just some of us is happy. Okay. So again, that are interesting. Has a certain kind of property Q of x. Okay. So this will be a different type of thing we can talk about. Some of the x that we consider, some of the x that are interesting, will have Qx to be true. Okay. So this will be a proposition. Okay. And the truth value, how do we determine the truth value of this one? So for instance, I can say some of us here is happy. I can say some of us is happy. So when will this be true? When will this be true? Remember, sum in mathematics, it means at least one. So if there is one, that will be enough. If there are two, that will be also okay. So if I'm saying some of us here is happy, then when will this case be true? If I'm happy and he is happy and she is happy, well, this is too strong. Okay. If I'm happy, or if he is happy, or if she is happy, that will be enough. Is that okay? So it is like, if there are different kinds of x that we can talk about, if for the first person, let's call it x0, okay, a certain specific person from this x, or another person x1, or another person x2, or ... If any one of them is happy, then we will say some of us is happy. On the other hand, if all of them are not happy, then we cannot say some of us is happy. Is that okay? So the truth value of this one is exactly, we look at all the possible x's and find out whether one of them will make this Qx true. If one of them is true, one of them can make this Qx true, then we say true. If every one of them cannot make Qx true, then we will say false. Is that okay? Okay? Good. And now, shorthand notation. So what is the shorthand notation for this one? This is this one. Okay. So this is a strange symbol, but you will soon know. So here, this symbol reads as there exists. There exists. There exists. There is some x which exists. Okay. There exists some x such that Qx. This is how it reads. And by this time, I guess you know why we choose this strange notation. So this looks like what? E. Okay. So this is exist. Okay. One is for all. It looks like an A inverted, and this looks like an E flipped. Okay. Oh, of course, you don't invert the E. If you invert the E, it is still the E. Okay. Right? So that's why for all, you do it upside down, and for E, you do the left-right, the mirror image. Okay? Let's test our understanding. Okay, so I have some simple example to test you. So first of all, for all x, so this is about for all, we have x squared greater than or equal to x. Is it true or is it false? Is it true? False? Okay, I give you a trap. Okay, you should still ask me what is the domain of x. If you don't ask me the domain of x, then this is still not well defined. Is that okay? Okay, so now I tell you, let's say the domain of x is, let's consider all integers only. So they are integers. Is it true or is it false? It looks like true. Okay, it looks like true. Okay, so let's check three cases. We can group all the integers into three cases: positive, 0, or negative. Okay, if it is a negative, then this side is positive, this side is negative, so it will be true. So whenever x is a negative number, then this part is always true. Okay, if x is 0, then 0 squared is greater than or equal to 0. Okay, now if x is positive, then what will happen? Okay, if x is positive, first of all, we look at 1. 1 squared is greater than or equal to 1, so we know this. And then if we consider a number greater than 1, a number that's greater than 1, the x squared is at least, so x is positive, greater than 1. So x squared must be strictly greater than 1 times x, because I'm replacing this x by a smaller number, so it's still large. So x squared will be greater than 1 times x, so it is greater than or equal to x. Is that okay? So in that case, after we consider all the possible cases for x, we can confirm that for all the cases, no matter which x you choose, x squared is really greater than or equal to x. Then in that case, we can safely say that for all x, this one will give us a true proposition. Is that okay? Okay? Now if I change the domain a little bit this time, if I change the domain a little bit, so let's say this is a real number. So x will include not just integers, but also real numbers. Then suddenly, the whole story will change. It is because, let us look at the value of x to be 1 over 2. Okay, if x is 1 over 2, half, okay, the square of x will be 1/4, 1 over 4, right? 1 over 4 will not be greater than 1 over 2. So in that case, suddenly there are some cases which makes it false. And then the whole thing will become false. Okay? All of them true, true. Some of them false, false. Is that okay? Good. And let's see. Okay, this time, again, for instance, there exists z such that z squared is greater than or equal to 10. Okay, is it true or is it false? Okay, of course, you won't be tricked again. This time, I will need to define the domain for you. Okay, so the domain, it need not be always very, very large. It need not, we need not choose a domain to talk about integers. We need to choose a domain that talks about real numbers so that the domain is containing infinite things. So we can define a domain that x can choose from. Maybe you can just choose x to be 1, 2, or 3. This is the domain that you have. Okay, you cannot choose x from anything else. So 1, 2, 3. Okay. So if this is the case, if the domain is like this, okay, you can only choose x to be 1, you can choose x to be 2, you can choose x to be 3. Then would this be true or would this be false? False. Okay, false. Because neither of them will give a true, so false or false or false is still false. Okay, but of course, if I change the domain to be something different, maybe this time, let's say the domain is real, okay, then in that case, you can easily find some set from the real, which makes it true. And then one of them, just one, will give the whole thing true, because it talks about there exists at least one. Okay, good. Let's see if you can translate this. This is more difficult than before, okay? Okay, for instance, so first of all, we are talking about for all x. But then we look at x, what are the interesting x that we are looking at? So for all x such that what? Such that x is greater than 0. Let's say the proposition says, for all x such that x is greater than 0, x squared is greater than 0. Okay? Is that okay? Now, if we want to translate this into the form that we look at, so first of all, for this one, we still have shorthand notation. Usually, we will write down something like for all x, but we have a little bit more about this x. It's not just the plain x that we talk about. For all x greater than 0, so this is bound together, that talks about what are the x that are interesting. Then the function here, x squared is greater than 0. Okay? So this is a shorthand notation. And even shorter than what we have done before. The shorthand notation that we have used is always for all x, some proposition px, right? This is what we have discussed so far. But here we are what? We are doing things here to make. So here, this is where x is greater than 0. Okay. So we are now moving this part inside. So it is even like shorter than the shorthand that we have used. Okay, but still, there is always a way to transform this shorthand notation back into a form like this. So I will write down two possible solutions. Only one of them is correct, and you will decide which one is correct. Okay. So first of all, this one is okay. The first one is for all x. A very long one, x is greater than 0 and x squared is greater than 0. So this is the part that we are talking about. So I'm making it like this, inside this one with an and. Okay, so this is the first case, 1. Okay, let me give you another case. This is 2. The second one is we still have a for all x. Is that okay? And then we make a very large proposition function, px. It says x is greater than 0 imply x squared greater than 0. So here, the condition is now put here, but then the symbol that follows is an imply. Yeah, which one is correct? Think about it. Yeah, it takes some time. One of them should be correct. Okay. Okay. Let's get a vote. Okay. So if you know, of course, you can tell definitely which one is correct. If you don't know, make a blind guess. Okay. If you think this option 1 is correct, you must choose. You must vote. Okay. If you think this option 1 is correct, could you please raise your hand? Okay. So like, let's say around 15. Okay. How about option 2? If you think option 2 is correct, could you please raise your hand? Okay, there are a little bit more. Okay, like 30. Okay, so it turns out that 2 is correct. Okay, the reason. Okay, let's take a look of the reason. So here, so what is the purpose of this one? This description. This description says, for all x that is greater than 0, these are the x's that we are considering. And if, okay, so for any x that does not belong to this case, let's say x is equal to minus 5, okay? Do we care whether minus 5 squared is greater than 0? We don't care. Because here, this thing is always talking about the x that is in that range. Is that okay? So when x is not falling in that range, we should, or we should at day 1, at the very beginning, we should ignore it. Okay, we should not be affected by all the x's that does not fall into this category. Now, if you look at case 1, now suddenly there must usually be some x that does not fall into this part, right? For instance, x is minus 5. And suddenly minus 5 greater than 0 will become false. Okay? False and anything will be false. And suddenly, for all x, you have some cases which is false, will make everything false. And then we are actually doing something that is 2 over, because the x that is minus 5, we should not talk about it at all at the beginning. But here, just this special case, minus 5, will make everything false, which is not our intention. Is that okay? So if you look at it, then this is not okay. Now, on the other hand, this looks like a filter. So it's like adding a filter to your camera so that you can take photos which has only one color or whatever. Okay. So this is a kind of a filter. So if x is greater than 0, it passes this case. And then we will then consider whether x squared is greater than 0. We will then consider the propositional function of that one. On the other hand, if x is not greater than 0, so for all the other cases that does not fit here, we will make this part automatically true. Remember, this is the property of this imply. False, if this part is false, no matter what happens in the latter part, the whole thing is true. Okay, so this will not affect, so the wrong x, the bad x, will not affect what we should consider at the beginning. Is that okay? So this is what I hope you to catch. Is that okay? Now, one more. Okay, there is another more. So this is the last. So the paraphrase. Okay. So for instance, we can also talk about. So this time I use there exists. This is easier to memorize because we are using the exist symbol. There exists x. Let's say with a certain property, x greater than 0, such that x squared is greater than x, okay, for instance. Then in that case, we also have a shorthand notation. It's like there exists what? There exists x greater than 0. So this is talking about this condition. There exists x greater than 0 such that x squared is greater than x. Okay? Now, again, for this one, there are 2 ways that can make this into what we have written so far. So we can write it as there exists x such that what? X is greater than 0 and x squared is greater than x. And then another case, there exists x such that x is greater than 0 implies x squared is greater than x. Is that okay? Is that okay? There are also 2 ways. Which one? Which one is correct? Only one of them is correct. Yeah, only one of them. Exactly one of them is correct. So what is meant by there exists? There exists is what? There exists is if one of them is true, then the whole thing is true. Okay. So there is a danger of translating this into this. The reason is that we can easily make this part true. We can easily make this part true. We find some x which is special. We find some x which is not greater than 0. So this will become false. Is that okay? False implies anything will be true, and suddenly everything is true. So in that case, we are fooled by something which we should not consider at the beginning. So if you think of we should not be fooled at all, then in that case you will quickly reject this one. This cannot be the correct translation. And then it turns out that this is the correct translation. So why is it true? Okay. So whenever x does not fit the condition, we will ignore it because this will be false. The whole thing will be false for that particular case. So it will not change the value of there exists. Okay, whenever there exists x such that the whole thing is true, then it means that we must have considered all the cases that x is greater than 0. And for all the cases that x is greater than 0, one of them or more of them satisfy this part. We need that, okay? And then this is what we have tried at the beginning. Okay, that's it. So this is what I want to deliver for today. So today there are two new concepts that I hope you can get. The first one is propositional function. So there's something which looks like a proposition, but we need to fit in inputs. Okay, once the input is fit in, then we get the proposition. So they are called propositional functions. And now propositional functions can be combined with quantifiers. Like for all there exists, or there exists one and only one. So we can talk about some very strange case. That there is just not exist. There exists one and exactly one. Okay, we can talk about some quantifier like that. To combine this with the propositional function to make a proposition. Okay, so if you can get these two things, then that will be great. Okay, so let's end the class early today. Okay, and then see you next week. Okay.